right, we have Shubhomoy Biswas on stage to talk about branch-based deployment strategy on AWS. Take it away.
Thank you. Thank you, everyone, for joining this session, and good evening to you. It's been exciting sessions all over the JFocus days, right? And I hope you will find this exciting as well. First, because it's an interesting topic or idea. And second, it's a lightning talk, so it would be 15 minutes. Thinking about that, I was thinking maybe we can take the questions if you have any after the session. So yeah, we can do that. Before I start, a quick background on me. Who am I? I am Shubhomoy Biswas. I work with Scania as a cloud engineer. My background is in computer science and software engineering. And few of my hobbies are sim racing, as you can see in the profile picture. I'm sim racing with the VR headset. And I also love running and sketching. And every now and then, I try to write blogs on some technical areas that I find interest in. And hope, yeah, this is one of the interest areas, so I also have written a blog. So follow me on Medium if you're willing to read more about this. And then who we are, what we do at Scania, okay? So we, in our team, are focusing on something known as hardware loggers. Okay, what are these? These are like special hardwares that we mount on our vehicles that can store and collect high-frequency ECU signals. Signals like, okay, what's the tire pressure, what's the oil temperature, oil pressure, what's the turning radius of the steering wheel, etc. So these are recorded and then uploaded to our data warehouse. So we in our team are a bunch of data engineers and data scientists who develop the data pipeline on the cloud and also maintain the data warehousing as well, and build a platform for data engineers and data analytics to do certain type of analytical and statistical work on top of this huge data set. And as we are building a platform, you might also notice that, of course, we need to take care of monitoring and logging as well. So that's a short introduction about our team. And focusing on this session, I just wanted this session to be a kind of a knowledge share, like what we did, what challenges we faced, and what ideas we came up with. I'm not saying it's the best idea or it's CI/CD manifesto that you should follow. It's always use case specific. So it's just an idea that came into being, and we found multiple benefits of it. So, and the session is more like, okay, how did we refactor our CI/CD pipeline in order to simulate multiple development environments within the same cloud account? Just a quick questions. How many of you are already on AWS? If you just raise your hands. Okay, that's quite many. But a quick disclaimer over here that I added on AWS, but then I later realized that, okay, it can be any cloud provider you want. It's about the CI/CD. So it's about the idea that we followed. So let's start with it. So how does a typical development workflow look like? I mean, it's a very generalized way. I mean, we are developers, right? So we write code, then we run our CI/CD pipeline. It builds our code, builds some packages, and then deploys it to our cloud environment, right? And according to your use case, you might have multiple cloud environments, dev, test, prod, pre-prod, I don't know. But just to be clear that, okay, what I'm explaining and what you understand here, like today I will be talking about only the dev account. So just think about, you just try to connect the dots here. Like whenever you're working, you wanted to push your changes and deploy it on like a dev setup, sandbox setup, so that you can test your code and then you might promote it to other environments. So whenever I say cloud, I mean development, dev account or sub account you have. And how does a typical deployment workflow look like? Let's say you are making a microservice or any kind of services. You have a Git repo, right? You create a feature branch out of it. You develop on that, and then you run some unit tests. You do some local programming, peer programming as well. And then you submit a merge request that then gets merged to your, let's say, main branch, and then the CI/CD takes over. It then deploys your service to your dev cloud account. And there you can test things out. And maybe then later down the line, you might have like end-to-end test, integration test, and then you promote it to different environments. But here's the thing. What we wanted to have is to give the developers a chance to test their code on the feature branch in the cloud. So in order to do so, whenever they push any changes to their feature branch, our CI/CD must deploy it to the dev account. Okay? And then after merge request is created and we reviewed the code and then it gets merged to the main, we want that to be deployed to the different account, like the test account, and then we run the E2E tests and then we deploy to the prod account. So this is something that we have. Why? Because, developers can test their code directly on the cloud itself. But there's a small challenge here. Maybe some of you have already got it. Because we only have, we are a team of like 8, 9 people, and we have a sub-account in AWS. Okay, this is your AWS sandbox environment. You can deploy, you can do whatever you want here. But there's a single development account, and we have multiple feature branches, right? So here's a quick illustration. Let's say it's a simple architecture, let's say AWS Lambda that is interacting with an S3 bucket. And the Lambda code is checked in a GitLab repo. So Alice wants to add a few lines of code, maybe add a new feature. So she creates a feature branch. And like I said, we wanted our pipeline to deploy to our dev account. So it gets deployed, Lambda is updated. And you know what? Alice did not want to test the code right away. Okay, she went for a quick rest. At the same time, Bob comes in and wanted to fix a bug in the same Lambda. Okay, so what he does, he creates another feature branch. And like I said, we wanted our pipeline to deploy to the cloud. Guess what happens here? It gets deployed, the Lambda is updated. As you can see, the code base is isolated, but our resources are not. So when Bob tests his code, it works. But Alice changes, she's a bit confused why it is not happening. So what does Alice do? You know what? She just adds a new line and then commits and pushes to the feature branch just to deploy the code. And then it gets deployed. And then when Bob, maybe she deployed that today, and Bob comes in tomorrow and checks his code and he's like, okay, what happened there? Like, my code was working yesterday, but now it's not. Typical developer's behavior, I guess. So we wanted a deployment isolation. So even our code base is isolated in Git, we wanted to have the same thing in our cloud. And then we thought, like, let's say hypothetically we have different development environments, but how would our CI/CD know where to deploy? Like, okay, this feature branch will update this set of services in the cloud. So how would we do that? So the idea that we wanted is similar like this. So we have one in the green box, you can see our dev account, sub-account. Every feature branch will have its own set of infrastructure. So we designed our infrastructure in a way, and all the resources will be identical. But the CI/CD will be able to, okay, this feature branch will only update all these resources, whereas Alice's feature branch will try to deploy the other set of resources. We wanted to have something like this, and when, of course, we merge, everything will be destroyed. But in order to do that, we need to go through some certain processes. That's why I wanted to share those with you guys. So these are some of the most important points. And the first one is, of course, the most important, is we needed to define a good naming convention for all our services in the clouds, all our infrastructure resources, okay? As an example, it can be like your product name, then your resource type or name, and the most important part is the suffix, the environment. And I will talk about that a bit later here, because your environment we will see will be a unique identifier, okay? Then after you have defined your naming conventions, you needed to identify, okay, what all services in the cloud you are using, okay? And then try to segregate them. What are the base resources? Like, for example, a cluster, a database, an OpenSearch. And the other resources will be like where your actual code base is deployed. In this case, you can see the Lambda, where the code base is deployed. It can be EC2 instances, a server, or ECS task as well. And then try to group them. Why group them? Because you need to write the infrastructure as a code. if you're not doing infrastructure as a code, then please scrap all this idea. You need to write them ASAP, because this idea is based on that. So once you have written the infrastructure as a code, you will try to parameterize that. You need to add placeholders, because in these placeholders, your name will come in. And then you tie it up with your CI/CD pipeline. So then you will pass that unique identifier, which I will say what we use as a unique identifier as an environment, and you pass it to all your microservices. Some notable mentions are GitLab CI commit, commit branch. So this is because we use GitLab in the CI/CD. This variable gives us the current branch the developer is working on. And we use this to populate the name, the environment variable. And of course, we use job rules and trigger jobs to, when to run our jobs, when to trigger different pipelines in the repository. Of course, you might be thinking, okay, we are replicating the resources, so maybe my cost will increase. Yes, but there are some few optimizations that you can follow, like I talked about the base infrastructure. So those can be like deployed once, and on top of it, you can deploy these dynamic infrastructure like the Lambda and the EC2 instances. Also, as I said, once your branch gets merged, we destroy or vacuum the resources as well. And this is the most important part. We use the Jira ticket ID as our branch name. And then because this is unique, our resources are unique. So our CI/CD knows where to deploy in which, and update which services in the cloud. And also, you need to think about, do you need to deploy all the services in the cloud for your feature branch? As an example, let's say these are 3 microservices you wanted to deploy. Maybe in the repository of microservice A, you don't want to deploy the ECS cluster or storage B. Likewise, if you are working on repository of microservice B and C, you might not need to deploy a queue and a storage class A. So those things are really beneficial. So yeah, like I said, with this idea, we kind of reaped many benefits. One is increased reliability of the developer. They can work independently in an isolated environment. We have increased the development speed. And most importantly, we can simulate the same production environment in our dev account just by creating a branch and deploying it. So we can reproduce the bugs in the dev, test it, and then in the next iteration, we ship our code. So yeah, I mean, since it's a lightning talk, so it was a really short one. But if you wanted to read more about it, I've, of course, added a blog post in Scania's page. And this is what we do in Scania. Like, we try to promote this kind of innovations and bring the developers up, speak like, OK, what new things are they doing? Again, like, this is not the best way or the must-have. It's according to your use case. Yep, that was it. I hope you liked it. Thank you.
We have 2 minutes for questions.
Yes.
What is the overhead of creating the resources? What is the overhead when you need to create resources on every deploy? Can you reason about that?
Yes, I mean, many said like, okay, every time I push, I need to wait for that. But again, like as I said in the previous slide, it's up to you, like, okay, which all resources you want to deploy. So you can use the job rules to like, okay, do I need to deploy another ECS cluster or a storage class B to mitigate that time, reduce the deployment time. So I think that's more, the time is more of a challenge here. Like every time I push, I need to wait. But then you get a real quick feedback what my code will be doing in the cloud itself.
Any other questions? All right, thank you very much.